I work at Vortex. I've been in the wind industry for 20 years, mostly working with weather models, right? And providing wind data for the wind industry. Okay, so let's go. Where have I to point this here? How does it work? This way? Okay. So this is the items that we will cover, okay? Um, thanks to Han, I had to reduce a little bit my presentation, but I feel comfortable because he made some of my job for the presentation. But so we will be also talking more about histograms, right? Um, but then I will talk also about different things that happen when you simplify your time series and your data. Okay, what you are losing, and to be clear on what you get from each data format that you are working with. Okay, and last we will try to see how this applies to Asia, right? So when I was coming here, okay, uh, I I said, okay, I must go on the field, okay, to see the local winds. So I went down to Thailand, right, to see if I could continue learning for this hobby. Okay, in in Spain, I just in summer, okay, that's the time in the months that I can. I just wake at 12 a.m. Okay, and I know there will be wind. Okay, but the other day I was going to wind falling, and there was a wind was blowing. Okay, earlier. Okay, so it's not the same pattern, but it's continuous every day. Okay, every day, the same as in the summer. But in the summer, what we have is it's a sea breeze, right? It's dominated by the difference of temperature between the sea and land. Okay, but this only occurs in at least in Spain in the summer. Okay, because it's when there's really hot. Okay, we have winter and summer. Okay, so here when you move to other regions, okay, the people that we come from Europe and we say winter, summer. No, the first time I came to Asia, I put that in a presentation. Okay, and I said, okay, I will never not do that anymore. Okay, it's let's say okay, it's wet and dry, right? Okay. So what happens when it's not summer, right? In mid latitudes, the winds are dominated by low pressures and high pressures. Okay, and it tells you how the wind is blowing, right? So you must be following that every day, right? The effects, wind effects, are not local or are not like monsoons, right? So now this is the situation if you want to go wind foiling in Thailand, right? When there's monsoon, okay, you know you will have days with more or less wind, okay, but it will be mostly southwest, right? Then there will be some transition months, and then if you are lucky enough to be near the sea, you will have sea breeze every day, same hours, right? Or depending on the temperature. So that's dominated by the clouds. Okay, that will change temperatures and so sea breezes, but you will have this kind of patterns. Okay, so now I will next time I come, I will try to come on well, not monsoon. Okay, so Marvin, next workshop, if it can be other dates, it will be better, right? So someone asked before about Weibull and histogram, right? Uh, Mid latitudes, especially Denmark, they were the guys who developed the wind resource at the very beginning, and their winds they always follow this pattern or almost always, right? The Weibull is a function, okay, that's defined by two parameters, right? the A and the K, right? The A, it tells you how big, how high is the curve, right? And the K tells you how far this tail goes, right? So with two parameters, okay, two numbers, you are compressing all the information that you have. Okay, for example, we are binning the wind speed every half meter per second. So you are having here 40 values. So you are passing from 40 values to two single values, right? 40 years ago, that makes sense because computers were very different, right? But I think that now we can afford to have that kind of that 40 per 40 plus values, right? For what Hans said before. Okay, we can see that there are different histograms, right? And we have much more information. Even in this shape, you see that the wavable is not fully representing the reality, right? So now I want to explain what a WBRG file is, right? It's simple, and it helps me also to represent what my experiments will show, right? I run a simulation in Thailand, right? It's northeast, so it's onshore, and we have this mean wind speed map. Okay, I select a point, and the WBRG file is a compendium of many wavable parameters in every single point, right? That you have in this area. So it gives you additional information, not a single wavable, but it gives you a different wavable parameters, so A and K, for different wind directions. So this shows the different distributions, and so the associated wavable fit, okay, for each one of the different wind directions, right? I don't know how many of you do use WBRG files. Is how many people is using WBRG files regularly or not? You, no, I will not tell. It's good. I mean, it's rare. It's rare that a wind engineer does not use WBRG files, at least for some preliminary study, or at least for whatever. Right? It's normal. I mean, it's the most common thing in Europe, right? Um, so what happens when with this? Someone said it's a double wavable. Okay, we do not call this double wavable. It's not a wavable, right? We call this fit a V model because it has two peaks. So when you see there are two peaks, we you should use another function, which is a V model, that it has two separate peaks, right? So if you now represent a wavable here and you forget about the wind distribution, you will be working with a reality that's not true, right? So we work with histograms, right? Okay, we work with histograms, but we can see a lot of things about histograms, okay? And it's not still a time series, right? It's a representation of a time series, much better than wavable, okay? Even if it perfectly fits the wavable, the histogram, it's much better because it has much information, but it's losing some information. In this case, okay, I'm representing the histograms for each hour of the day, right? So as you can see, they are very different. Well, at least there are different patterns, right? You see that some hours have similar patterns here. For example, these are for midday, right? And these in the night, okay, are also similar. Okay, so here it tells you that the histograms are mostly dominated by the hours, right? And what about daily cycles, right? Daily cycle, it's not, it could be also a histogram, okay? We oversimplify the word histogram to represent the frequency, okay, of each of the wind speed for each the occurrence of the wind speed for each bin, right? In this case, we represent the mean wind speed, okay, for each hour, right? So we can see how the wind increases or decreases when the day evolves, right? Where we start in the morning, okay. In September we have the higher wind. During the day it goes down, and at the night it goes up. Okay, so that's another way to see the wind pattern, right? Apart from histogram, right? And this gives an information that maybe not, it's not directly associated to the wind yield, okay, the power yield, but it can be very, very important in some cases. Okay, so here we see that, for example, uh, December, January, and even February, that they have a different pattern, right? So when you are long term correcting, okay, you have you must be sure that you have all the shapes, right? If you are missing a December and a January, you will not able to correct the long term this kind of shapes, right? So it's important to see that to understand this, because when you find situations like long term corrections, you have the full the full picture, right? So we can simplify information with this kind of plots. I like, okay, because you don't with this you have a lot of different images, and with this you have the same information, right? But at a single glance you can see this. Okay, it just tells you that at the central hours of the day, well, at early afternoon, right? The spread, okay, we call this area, the spread is very narrow. So the mean value that you get from this, it's very representative, right? It will be mostly the same or for different months, okay, or even years, right? But if you move to the just the around the sunset, right? Here, the amplitude or the spread is very big, right? So if you say, okay, what's the mean wind speed at 6? Okay, okay, it's like around 7, right? Yeah, it's around 7, but it will never be 7, right? There will be times that will be 12, other 2, okay? But when you say that you are at 5 here, right? It will be the mean wind speed, the wind speed at this at 3 will be always much more closer to this mean value, right? So that's what we are seeing in this kind of plots, right? So the uncertainty of wind speed, I think uncertainty, it's a word that's appealing to every wind engineer, right? It's much lower in these hours that in these hours, right? So same plot, right? Mean wind speed, right? But in the x-axis, we have the months, right? We have the average instead of hours, month. So how the wind changes during the year, right? In this case, we can see that the variability is much lower than when we are looking into hours, right? But we can also see that there are some months, okay, that have less uncertainty, are more consistent, okay? For different days and hours, the values are much close. While when we go to January, February, or November, December, even October, okay, there will be much differences between different days and hours, okay? So we can see that the patterns, well, are dominated what I started at the beginning of the presentation. We can see here, right? There are climates. Okay, so when an engineer comes from other places that are not Asia, are not Brazil, they will not know nothing about this. You will have to explain them, okay, and make sure that these analyses are taken into account, right? So that's important because they sometimes they don't know this kind of situations, right? So this is how I'm going for- the extrapolation method, right? Uh, I think you did some kind of things like this. Extrapolation method is I have my simulation, okay, but I imagine I have 1 point time series, right, in the origin, right, and then I want to know how's the time series in another location, right? The typical way to do this is by if you have the time series in a point and if you have the mean wind speed map, okay, I can compute the ratio between the two. Okay, that's a very simple methodology of extrapolation. There are many more sophisticated. Okay, and that gives better results, right? Okay, but I will stick to this simple method. Okay, so what we got is above we have the original time series. Okay, and below we have the extrapolated on the target time series, right? They have all the same shape, right? But one is windier than the other. As you can see in the map, the original is on the bluer side, which is low wind, while the target is on the yellow side, which is windy, right? So that's what you can see in the red time series, right? So you have no time series everywhere, right? With this method, okay? But what happens when you collapse that time series into a histogram, right? Okay, if I get the original, um, the extrapolated time series, well, the two of the above, you have the origin, right? They are the same. As you can see, they are the same because for construction, both are the same time series, right? So they are the same histogram. But on the left, it's the extrapolated method. Okay, so you get a shape of this histogram which is pretty similar. It's not the same, okay, but it's pretty similar. Okay, we have moved the wind a little bit higher, right? So the histogram moves everything towards the right because it's higher winds on the x-axis. Same occurs on the real simulation, right? But the shape is not the same. Okay, so you are getting time series information, but you are losing some part of the reality, right? What you can do is install another metmask, okay, in the target, and then you would see some kind of this variability. So I want to uh, not quantitative evaluate this, but show some examples, right? So for example, yeah, oh, sorry. For example, here is the histograms of 4 points in the simulation, okay? And you can see each color is a point and a histogram plot, right? And you can see how the histogram changes, right? You can see that there are different shapes. They do not change a lot, okay? They still have the same shape, but for example, for the northwest part, okay, they have a bigger tail than this black one, right? So there are still significant changes, right? If you are making extrapolation method, you will see all the shapes are almost the same, right? Diurnal cycle, for example, you would say we would say here that we have 4 diurnal cycles that are pretty much more similar than histograms, right? So in this case, extrapolation method and real measurements or simulations would be pretty close, right? And what I find really interesting is this one because um, this is yearly cycle variability. It's just each month mean wind speed, right? So you can see that the shape is not the same because in the central months, okay, what we would call summer in Europe, okay, in central months, July, August, there are some points that have higher wind speed near to the most windy, which is December, while some others don't, right? So it's pretty variability here. So I call this the spatial variability. We are used to understand spatial variability by the mean wind speed, but you can see spatial variability through other plots or information, right? That can be diurnal cycle, yearly cycle, whatever, right? So in summary, for this first part, I wanted to show just this, that there are two kinds of variability, right? The spatial and temporal, okay? That the double BRG files, okay? They typically come from a simulation and have a spatial variability, but has the temporal information compressed, so they don't have temporal variability. While the histogram, the extrapolation method that you have one time series and try to expand that into the space, okay, you lose some spatial variability, right? And then also how to look at spreads when you have time series and you collapse. If you just don't keep the mean average, okay, and you keep the bands, right? That can be at 1 sigma or P90 P10 or P75 P25, whatever you like, but some kind of bands. Then you can rate that narrow or wider spread, right? And what it means, right? So why all of this, right? Um, there can be different um, reasons why you want to make your life more complicated, right? But from our expertise, for us, there's a clear situation when you can see that your project can be complex in terms of meteorology or variability or temporal variability. And you can know that in advance, very early stages. Okay. So if you see that variability map and different histograms plots in different areas at the early stages, then you can decide how complex your measurement campaign be, right? And then you can decide where your clusters, okay, of climate regions or climate areas will be, right? It does not make sense to put two manners in different places just because they have different mean wind speed, maybe. Okay, if they have different mean wind speed, but all the daily cycles, okay, yearly cycles are all the same, that can be easily corrected. Okay, but that's another talk. Okay, but that gives you some information. Okay, if with a simulation, and you can compare simulations. Okay, you can get weather simulations, you can get CFD, you can get WASP like linear extrapolations. You can make different kind of approaches. If all of them agree more or less with all the information, then it's a simple project. But if they disagree, then you have to look further and make deeper analysis. That's in my opinion. Okay. So other use cases, right? Practical use cases that I think just to have fun. Okay. If you like wind resource assessment, then if you have more information, okay, you can have more fun. Okay, you cannot be lost in some words, But if you understand better, maybe at the beginning of your project and take some time, sometimes it's not possible, I know, but if you have some time and make a good analysis at the beginning, then the surprises don't come at the end, right? So you can have more fun at the beginning, less stress at the end, right? Another use case, it's hybridation, right? When it comes to hybridation, for example, the diurnal profile, it's important, right? It's not for the same yield, it's not the same project like this. Okay, let me explain. Sorry, let me explain the plot. The wind, okay, it's the black one, right? And and the yellow, it's of course it's an imagined solar curve, right? So we combine them. As we see that the wind maximum wind speed is at night, it combines better because we know that solar will produce more during the day, right? So it's not the same if we want to hybridize in a place where the maximum is at night or is during the day. So that's some things that will be fixed, that you will have to look if there will come hybridation into your projects, right? So it's not that far, I think, right? Other, it's if you want to if you they will ask for storage, right? If you are going to put battery storage, I don't know how many people come from solar, but in solar they are more used to going for battery storage. So if they go for hybridation, then probably they will come battery storage, right? And then you will have to look for the same plots that they look, that's daily profiles, because in solar basically it's daily profiles, right? So that's another example of a use case where time series and this kind of analysis might be useful, right? So these are what I think that in this area it's important, this kind of analysis, because there are clearly yearly cycles, daily cycles. Okay, the market is grown, and it's not a child. Okay, wind energy has 40 years. Okay, so do not have to repeat all the mistakes that were done other places, right? And also there are particular electric network dependence, because the consumption is different. Okay, here, so it's important that local people from here develop their own strategies on wind resource, right? Uh, and then what I will repeat what I said in the first slides. Okay, the climatology, it's important to know and understand, right? But okay, that's all. Thank you.